Here we are in chapter 12, trying to finish up 12.5, probably 12.6. We'll see how many videos this takes. Let's get started. So the rational roots theorem says something to the effect where if I want to find all the possible zeros, we take all the factors of our constant. So that would be plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, 12, 24, and divide that by all the coefficients, or the coefficient on the highest power. So in this case, plus or minus 1. And this is all the possibilities, and if they say to make a list, that doesn't mean to write this. This is how you find it. You would say 1, comma, negative 1, comma, 2, comma, negative 2, dot, dot. You know, you would list them all out, but that's how you do it. And this is how you find them. This is the organization right there, is how to find them. Okay? So on this next one, I'm going to take all my factors of 6, plus or minus 1, plus or minus 2, 3, and 6, and divide that by plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, 12. And if I was to list all of those out, I would probably start, if I was going to go, I would probably say plus or minus 1, plus or minus 1/2. And if I was going to be listing them, I'd probably do it separately. So minus 1, plus 1, minus half, plus half, plus a third, minus a third. Make sure you're making all the possibilities for that. And now it says, so that would be your list of all the possible ones. And now, once you've made your list of that, let's go ahead and see if we can actually find some of these. So we're going to start out by saying, hey, if this is the auto theorem that I spoke of last time, if I add up all the coefficients, it comes out to 0. So I'm going to use my synthetic that we talked about last time. And I look at it and I notice that all the coefficients add up to 0, so I know that 1's got to be one of the answers. So I'm going to put in 1, multiply by 1, 2, multiply by 1, negative 23, negative 23, which gives me negative 24, which gives me a 0. And then if I want to give myself a little more room there, I'm going to, instead of rewriting it again, just like I did last time, I'm going to try negative 1 here. Multiply 1 by negative 1 gives me negative 1, add it together, negative 1, negative 24, add it together, I get 24. So I get an answer of 0, and these are the coefficients on my leftover, so x squared plus x minus 24. If I want to factor that, I get x. Oh boy, that doesn't factor. So I'd have to use the quadratic formula and I'd end up with something like negative 1 plus or minus the square root of 97 over 2. So that's two of the solutions. There's one, there's one. And over here, it appears as if it's a readily factorable thing into 4x squared and 3x squared, and I'm going to put in a minus 3 and a plus 2. If I do my inside, outside to check, I get 8x squared and negative 9, which gives me the negative 1 in there. And so if I set each of those equal to 0, I know that I get x squared equals 3/4, square root, and it'll be a plus or minus, so I get x equals plus or minus the square root of 3 over 2. And if I go over here and do this one, x squared equals negative 2/3, x equals plus or minus, and I'm going to negative -2/3. And just for the fun of it, I'm going to bring out the I √2 over √3, rationalize, which gives me plus or minus I √6 over 3. Not very nice, but certainly when we're talking about imaginary numbers, it's okay to have answers like that. Here we're going to talk about some lower and upper bound tests, and let's explain that a little bit. Let me leave it there. If you want to pause it right now so you can read through these, you certainly can. I'm going to try to explain to you how it works. So, if I have a row that looks like, when I'm doing my synthetic, and I get a row that starts out with a positive, a negative, a positive, a negative, a positive, like that, I know that that is going to be a lower bound test. So if any time that it alternates like this, that's a lower bound test. And anytime you get positive, 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 that is a upper bound. Now when it says upper and lower bound, in our polynomials when we graph them, an upper bound means you're looking over here where all of our roots are less than it. A lower bound test means if you get something like that, that means you're testing over here, and we know that the actual roots will be greater than it. If we look at this that I have over here, it fits neither one of these, and so what that means is it's probably somewhere in here, because it's not going to be an upper bound or a lower bound in that situation, because it doesn't fit the every other one or the all positive. So it's going to be between some of those roots. So let's go ahead and do some testing on this one and see what we can come up with. So if I use my rational root theorem, I know that I have a possibility of having roots at plus or minus 1, 2, 3, 4, 6, 12 over 1 and 2 plus or minus. And so I can have anything from 12 down to like plus or minus a half. I can go down into the negative numbers, -2s, -3s, something like that. So if I want to try a number like 4, I'm going to try if I try a 4 in there, I get my 2, 8, 1, 4, -1, -4, 24, 22, 24, and 96, 96, which gives me a positive 84. And notice that it's not an upper bound because we have 1, so we would say it's just not an upper bound. And then let's try something like a 6, a little bit bigger, because I know I hadn't been big enough on the last one. Let's go ahead and try this one. And I get 2, 12, 5, 30, 25, 150, 178, and 1,000. Holy cow, and it gets big, 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 big. But notice what we're looking for here is I have a line of all positive. So that means that we are at the upper bound of our answers. So all the answers have to be smaller than 6. And let's see if we can find a lower bound. If we do this and we test 2, -7, -5, 28, -12. I try a -3 in there, gives me a -6, -13, 39, which gives me 34, which gives me 102, oops, not 120, 102, which gives me 130, which is -390, and -402. And if you look at that, it alternates the positive, negative, positive, negative. And so we got a positive, positive. So that's not an upper bound either. But we know that the answer isn't that either, because if it was an answer, that would be 0. So let's try another one. We know that one's not a lower bound, because it would have to alternate. Let's try a -2. And I get a 2, -4, -11, 22, 17, -34, -6, 12, 0. So this is actually a 0. So there's 3 cases that we need to talk about. One, the upper bound, where all the answers are all positive. That's an upper bound. If our last number is 0, that's actually a 0. That means it goes through the x-axis. And if we get one of these alternating plus minus things, then we know that this is actually the lower bound, because it's alternating plus minus there, all the way to 0. So we know that those are the 3 cases that we have to look for when we're doing these upper and lower bound tests. Rational root approximation. There is no precise way to determine irrational roots of a polynomial equation, but method used even by calculator is a method of successive approximations. All right, and let's move on. And if I want to locate a positive irrational root, well, it's going to be a rational root, isn't it? I don't know, maybe it's irrational, I'm not sure. Let's find out. If I wanted to do some testing, I might want to do f of 3 gives me a -17. F of 4 gives me a 2. So I know that there's a 0 someplace between there, because it's going from a negative over here to a positive over there. So somewhere in between there. And if I test f of 3.9, I get -0.61. And if I go f of, well, we know f of 4 is positive, right? That's still positive too, so it's between those two. If I go with f of 3.92, I get -0.1029, and f of 3.93 gives me positive. So somewhere we know between here it's going to be between 3.92 and 3.93 is your root. And all we did was continue to get closer and closer by testing numbers. All right, I'm going to continue on the next video.